Okay, welcome everyone and really appreciate your time spent to join us webinar today's. Hope you will get some information from here. Topic is Minitab Statistical Software, Regression for Predictive Analytics. I'm Nur Sulawati. I'm the Technical Support Specialist at Busy System. Busy System are independent local and representation for Singapore, Malaysia and Batam, Indonesia. So today, I think most of you coming maybe interest with the predictive analytics itself. So predictive analytics can help company optimize your existing process, maybe better understanding the customer behavior, and then maybe you can identify the unexpected opportunity and anticipate the problem before they happen. Okay. So before we get started, there are a few housekeeping notes before we get started. We have a Q&A session after the presentation. So please submit any question you have, and we will try to our best to answer them if have a time. If no, we will answer afterward by email. We recommend that view this webinar in your laptop or PC for best result. Please fill up our survey before you exit the tab. This survey will help us to improve the quality of our upcoming webinar. We record this webinar and upload to our website, www.visit.com, and our YouTube channel, Minitab Malaysia and Singapore. So that's no problem if you miss anything or want to review afterwards. Okay. So if let's say you want this material also, you can drop your email, okay, in the chat box, and I will email after this. Okay, so Minitab was developed in 1972. Okay, so today's Minitab in market for 50 years. Okay, Minitab Statistical Software is software package for the statistical analysis. So variety of statistical tools available. I will show after this. This software will be powerful statistical software since everyone can use, whether you are a statistician or non-statistician or data sciences or non-data sciences. Okay, so now Minitab itself is a company, but in under Minitab itself, we have a many type of product. Okay, our flagship product is a Minitab Statistical Software. I think most of you know about this one. This one is a statistical analysis, but we have others other product like Minitab Connect. This one is more for data accesses or dashboard, something that one. And then maybe you can go for the predictive analytic. Okay, or we have a predictive modeling. We have the SPM, we call the Suffolk Predictive Modeler. And then we have online training, something like Quality Trainer. You can see on that we are a lot of topic inside the Quality Trainer itself. And then we have something like project execution. We have a Minitab Engage, and then we have also Minitab Workspace. So, but today we focus on the Minitab Statistical Software. Okay, and then of course we have a lot Minitab industry or being used our software. Okay. So here some of the tools are available in the Minitab Statistical Software. For example, I think most of you coming from the quality side. Okay, so we have a measurement system itself, not only the gauge study, maybe you can go for the linearity, something the bias one, or maybe your data is something like acceptable just yes or no. You can go for the attribute algorithm analysis, also available in the MSA. And then we have the control chart, we have the capability analysis, okay, and then we have acceptance sampling, and then we also have the tolerance interval. So if let's say you want to something like statistical quality control, so this part is this tools is available for you. Okay. So we also have reliability engineering also, and then with the latest version 21, we added new thing as we call it the COG regressions for the reliability engineering. And then we also have something like data driven, and then this one is maybe we go for the DOE, design of experiment. The tools is help you to do something like optimization. So after you know your process is capable and then your process is stable, maybe you can go for the another step. We call that optimization. So if let's say look on that one, so we have a DOE. So not only the full factorial, we have something like response surface. I think most of the real case study is a look on this DOE is using the response surface. And then we have also something like business analytic. Okay, so we have a statistical modeling. So for today's, we focus on the regression. Okay, and then not the only regression we have, actually we have something like classification and regression tree is we added starting with the Minitab 19. You're able to see on the Minitab. We also have something like time series. Your data is in time order, something like minutes, second, year, and so on. But you want to do prediction, so we have the time series analytic, and then we come in with the new visualization. Okay, we have a heat map, we have the bind scatter plot, we have a program on this one for the part of the business analytic or predictive analytic. And then this one also we have something like process validation. Okay, but just to highlight that this one is not the in sequence. Okay, all this code not in sequence like this one, but these two are available in the Minitab Statistical Software. Okay. And then, of course, since we have a complete tools for analysis, so our customer coming from various of sector, including manufacturing, academician services, and so on. Okay, so to this webinar, we focus on regression. Okay, for those are familiar with the DMIC concept, maybe regression normally we use in the measure or analysis phases. Okay, but no worries if let's say you are first time see on this one about the regression. I think a lot of us, we can use the regression, something like in our life. We want to know about the price of the house. This one is something like that one. Okay, so you go to the market research, you do something like you ask the agent and so on. So you collect the data set. Okay, you collect the information. So from there, you know this area. Okay, maybe the house for this area about the range this value to this value. So it's something that one. So if let's say you look on that one, so regression is applicable for you. Okay, but starting with the Minitab 19, Minitab enhance the features in the regression tools in order to help our customer use the regression, be one of the model for their analytic project. So no worries now if let's say you want to do predictive analytic project, so Minitab with the regression is applicable to do. Okay, I will show after this. So but within 1 hour, I will cover some basic before we go for the details one, and then I will cover to how to run the regression in Minitab. Okay, hopefully we'll get some input from this webinar in order to enhance your ability to use the Minitab Statistical Software. So let's start with our webinar today. Okay, so regression is something like classical tools for building the predictive analytic. Okay, regression allow us to model the relationship, okay, between a response and a various predictor. So response here can be, you say that this one is output, okay, the same thing, or maybe you say that response is can be like Y, okay, the predictor something like your parameter, you call the parameter. So we call this one is parameter or dependent or independent variables, the same thing but different name because it's coming from different industry. Okay, but for today I will use the response, mean that output, mean that your Y, and then the predictor, mean that your parameter or your X. Okay, so this one is from regression itself, you able to determine which input So input here is your predictor, okay, and then you can do the prediction, okay, to the response, which is one of the most impactful. So your aim want to do the prediction, so you want to do the prediction like how to predict the yields of your process, okay, for this month how many years you need to produce something that one. So you can use the regression, okay. Maybe you have a lot of historical data, or maybe your process now is a good, okay, so it's a good means that in control and then capable. So what next you want to do? So maybe you want to know about what the criteria, what the input impact to your process. Okay, for example, it's your diameter, something that one is your response is a diameter. So what are criteria or what are the variables impact to your diameter? Maybe your temperature, something that one. So you want to that kind of the objective. So you able to use the regression. Okay. And then for information, regression is something like equation. Okay. So in mathematical equation, you can see the standard one or general equation is like the one is a y equal to mx plus c. I think this one is a basic one. If let's say we were during to the secondary school, so we always see y equal to mx plus c. So it's the same thing, but maybe now your relationship is a complex. Maybe can be a quadratic, okay, maybe can be a cubic, or maybe be a linear. So majority of us using the linear regression since it's easy to explain it. Okay, but your modeling can be a quadratic, or we call it non-linear. Okay, non-linear regression also available, or we something like a cubic. Okay, so the quantity is something like y equal to x power of 2. Okay, something that one. Cubic is y equal to x power of 3. Okay, something that one. Okay, so so who will use it? Okay, what industry is relevant? So for me, I think this regression is relevant for all, as long as your objective want to do the prediction, and then it's of course it always depends on your data set. Okay, so everyone can use regression. Okay, so for example, you want to do something like modeling of your cycle time, you want to know about the quality score. Okay, you want to know about the cement, the strength of your cement or plastic strength or something that one, or you want to know about the yield itself and so on. Okay, so for example here, if let's say you want to know about the analyzing the factor, you want to analyze the factor that effect to the percentage of crumble potato chips, okay, for containing before shipping is your response variable. So the factor here, something like ingredient itself, okay, and then something like the cooking or temperature itself. So as we know, ingredient only one type of ingredient. Maybe you have ingredient A, ingredient B, ingredient C, and so on. Maybe for the cooking temperature also, you have something like 20 Fahrenheit, something that one or something. So that one is you want to know what factor, okay, is most impact to your response variables. Okay, so if kind of this situation, so you're able to use the regression. Okay. So many type of regression in the market, also many type of regression in Minitab itself. So how do we choose them? Okay, how you want to choose it? Okay, so it will depends on your your response. Okay, means that your yield, okay, something that one, your strength, your Y. So it's a depends on your Y type. So basically, it's continuous, it's measurement, say in numeric. So you have something like numeric. So you can go for the simple regression. Maybe you can go for the multiple regression. So simple here is referred to only one predictor, one X impact to your Y. So now, for example, you have something like you want to know about the duration of the boiling, okay, water. Okay, your Y. So you use your you look on the time, you look on the temperature of your liquid you use it. Okay, something like one. So the only one. So that one consider only simple regression. Okay, but in Minitab, we not call the simple regression. Okay, we say that it's a fit regression line. I will show after this. And then for the multiple regression, it's a more than one predictor. So you can go for the multiple regression. So if let's say your relationship is not linear relationship, so maybe you can go for the non-linear relationship. So if let's say you want to see linear or non-linear, so basically we back to the basic one. We start with the visualization. So you need to go for the visualization. So for this case, for know about relationship, maybe you can go for the correlation, or new added within the Minitab, you can use it the correlogram to see on the relationship. And then of course we have something like partial least square. So this one is something like you have something correlate with your predictor. So you have a lot of things, so you can go for the partial least square. Okay, so this one is a Y when your Y is continuous or measurement. Okay, but when your Y is a discrete, okay, but only two outcome, okay, but only two outcome, yes or no, so you can go for the binary logistic regression. Okay, but if let's say have a more than three, okay, you can go for the ordinal logistic regression. If let's say if let's say your outcome more than three, you go for the nominal. If let's say your outcome more than three but in order, something like scale, Likert scale, okay, 1 to 3, or something like satisfied, not satisfied, very satisfied, something like one, so you can go for the ordinal logistic regression. So if let's say your Y, your response is something like event, your probability something like one, so you can go for the Poisson regression. So this one, all this regression is available. So we show how to see on this one. Okay, I open the Minitab. So hopefully you can see the Minitab. Okay, if let's say you see, you type 1 in the chat box. Okay, the Minitab interface. Okay, okay, thank you. Okay, so when you want to do the regression, so you can almost start with the start menu. So in the start menu, so you go for the start menu, you go for the regression. Okay, you choose regression. You see that fitted line regression ISAF, you have a non-linear regression, you have a partially squared regression. But for this case, if let's say you have only one, so you can go for the fitted line, only one. So only one X here. Okay, only one X here. So if let's say you want to look on the multiple, so you can go for the regression. So go for the regression. So you can see the fit regression model. So in your mind now, if let's say look on the multiple, for Minitab, we call the regression. It was simple, simple one, you would took with the fitted line plot. Okay, so others one, something like binary, logistic regression. Okay, we have ordinal, we have the nominal, we have the Poisson. So I think in 1 hour, I cannot cover all this one. So I just focus on the regression. So mean that multiple regression. Okay, but the objective here is the same. Okay, just different type of the regression. It will depend on your response. Okay, so we're back to the presentation. Okay. So other thing you need consider if let's say using the regression. Regression is a statistical method, so you need to fulfill some assumption. Okay. So the first one, okay, you need to check okay your assumption on your residual plot, whether it's a normally distributed or not normally distributed. So for this case, we have need to follow a straight line. So if let's say straight line, so we consider that the residual is the normally distributed. Okay. And then the second thing you need to look on that is a constant variance for our fitted value. So you can see that this one is the constant value. If let's say you have a non-constant constant variance, you can see that this one is increase. Okay, maybe you have a pattern here, increase or decrease, something that one. So this consider that this pattern is a non-constant variance. And then the other thing for the third one, you must be our schedule is a random over the time. So the plot should be randomly around the center line of the zero here. Okay, so this one is a must be look before you rely or before you do the prediction. Okay. So let's we try with this example. Okay, so for this example, they want to the energy uses commission. Okay, and then the predictor they assess on this one is the total unit produced. Okay, total equipment runtime, your employee hours, your mean outside the temperature, the minimum outside the temperature, maximum outside the temperature, your percentage of sun, and the mean equipment age. Okay, so I will go to that data set, easy to see it. Okay, so this one is your predictor. The mean temperature, the mean average temperature, the minimum, maximum, your percent sun, unit produce, and then our response is a energy. So with this condition, okay, with this condition, so this the value of your energy. So now you want to something like what kind of the predictor in most impact to your energy. So if let's say this one is the change, what happened to your energy? Maybe for this case, you want to something like energy, reduce energy. Okay, want to something, reduce energy. Your objective, maybe you need to look the hours maybe, okay, before you go to the data set, maybe you use the gut feeling. Okay, so to decrease the energy, maybe you need to decrease the employee hours. Okay, so maybe you need to increase the total equipment runtime. So based on your gut feeling, maybe nowadays we using the data set. Okay, you collect a lot of data set, you using a sensor, something that one is smart one. So you can capture every type of the data set. So that kind of this situation, maybe regression is available for you. So no need to like, okay, if let's say you want to increase, decrease the energy, maybe you need to increase the employee hours. Okay, so maybe you need to decrease the total runtime. But in your mind now, if let's say you have a two here, you have two interaction between the total equipment run and then the employees hour. Okay, maybe you have interaction. So if let's say you decrease, this one is or decrease, and then you see that the energy of BR increase, not the decrease what you say. Okay, is that one is based on the gut feeling. So now you can using the regression to help you on this one. So that one, we have a predictive analytic project on this kind. Okay, so for this case, okay, but before that, maybe you not want to know how many data set you have. Okay, so you just go that worksheet, right click, and then go for the worksheet information. Okay, so go this one, right click, choose the worksheet information. So in this worksheet, you have a 10 column. Okay, and then your number of this observation, the data set is 20, and then they provide you the column name of this one. Okay, start for this one. Okay, so now your response is energy. This one, all this is your predictor. So more than one. So you need to use the multiple regression. So how? Go to stat, go to regression, fit regression models. For this response, you choose the energy. So on this one, I choose this. So if let's say you have categorical predictor, you include in this column. But now I just only have the continuous predictor. And then you go for the graph. Okay, graph, why you need go for the graph? Because this one is the statistical tools. You need to do the assumption. Okay, that one, you choose the 4-in-1. Maybe you go for the Pareto to see on this one and click OK and then click OK. Okay, so now you get the output. I will go to stat, go to regression, fit regression models. So you fill up your dialog box, your response, and then your predictor. Okay, if you want to look more, you can go for the models. Okay, so you want to assess on the interaction, maybe you want to have not the only one, only two, maybe you go up to this one. So you can have your own model here. Okay, so but for this time, for the starting part, just using the default one, and then you click OK. Okay, and then you get this output. So now this one is a regression equation. Okay, you can see that this is energy, is your Y. All this one is your X. Okay, so based on this model summary, so you look on the R squared. Always the first thing for regression, you look on the R squared. Why R squared? R squared is the how many percent variance is explain it. Okay, variance on this. So for this case, R squared must be 1 to 100. Okay, the value R squared must be 1 up to 100. So if let's say highest value is a good value. Okay, it's a good model. We said that it's a good model. But this case will also depends on the how many variables you include. Is it in interaction or something that one? But just today, we focus on the R squared. So based on this R squared, this one is the highest, okay, more than 70%. Okay, so that one, we consider this is question is a good question. Okay, so you can do the prediction based on this is question. Okay, but another thing you need to look is the simple models is a good model. Okay, simple model means that less number of the predictor in your model. Okay, for this case, you look 1, 2, 3, 4, 5, 6, 7, 8. 8 predictor you need consider to do the prediction for energy. So you need consider 8 factor. Maybe this one you need have refit or find out the simplest model. Okay, so you need to find out the simplest model. Okay, for this case. So in Minitab, actually we have something like we call it model selection. Okay, Minitab will help you on this one. So for this case, we have the model selection can be automated. So there has a 3 common procedure are available in Minitab. The first is based on the p-value. So you need go for the ANOVA tables. Okay, just now we show it this ANOVA table. Okay, so you go for the ANOVA table, you look on this value. Okay, p-value here is a less than 0.05. It's significant, so must be in the equation. Okay, so you look on that one. Or another way, we have an information criteria for model, or we call it AIC or PIC selection model. And then we also have another procedure is we call it R squared value for predictive fit of the model. So for this case, we have K-full or validation with test set, forward, and so on for this case. So we have a 3 type of common procedure to automate or to select your models or your equation. So for today's, I focus on the only one. We call it the stepwise regression. Okay, so that one is a stepwise regression means that words like you have you start with the zero predictor, and then you add, you add and remove up to the alpha to enter it, or up to the alpha to remove it. So you have a this enter, but this value is a default by the Minitab. Maybe you have the other values, so you can put the others value on this dialog box. Okay, let's we try with this one. Okay, so the same case study, but now we want to have a simplest model. Okay, so how to go for the start regression, fit regression. Go back to this dialog box, and then you can see the stepwise. Okay, so in this stepwise, you have a method here. Okay, so a stepwise, we have a forward selection, we have backward elimination, forward criteria, forward selection with the validation. So this one is the new one. Okay, just added starting with the Minitab 20 for this forward selection with the validation. Okay, so for this case, I will try with the stepwise first. Okay, choose the stepwise, and then they give it to this one, and click OK, and then click OK. Okay, now you get the new regression equation. Okay, but with the simplest model or simplest number of the predictor. But you look on the R squared, it's quite high also. So maybe you can consider this equation is a good rather than the first one. Okay, so this one is a complicated. Okay, it's a complicated because a lot of predictor. So this one is a just nice, maybe a 3 out of 8 here. So just nice to do the prediction. Okay, so just nice to do the parameter settings, so on, so on. So this one. So how to do it? So go back to the dialog box, you look on the stepwise. Maybe you can try one by one for the forward selection or backward elimination. But for the stepwise, they add and then they remove at the same time. Okay, so if let's say forward selection, they just only add. Okay, for the one is the remove. Okay, something that one. But for this stepwise, they give it you both of them. Okay, so based on this equation and then based on the model summary is quite high, you agree this one is the good one. But remember, you need to check your assumption. Is it fulfill your assumption or not? So go to this residual plot. So based on this straight line, okay, you can form the straight line. The residual is a normal distribute, and the fit residual also is called constant, and then this one is scatter on the 0. So we consider that this one is a fulfill the assumption, and then based on this value, this equation can do the prediction. So you satisfy with this equation, so you can go for another step we call the prediction. So how to get the prediction? You go to start regression, you choose the predict. Okay, so you choose the predict. Okay, this portion, okay, this option, this part is will be not the grayscale when you have fit data set. You already run the regression. So after you run the regression, so you able to see the others, like predict, factorial plots, contour plot, and so on. For example, I go for the binary logistic regression. Okay, so you can see it's in gray. Okay, in gray. Okay, not appear. So means that you not able to do the prediction since Minitab cannot get something like fit model like this one. Okay, so that one you're not able to run the analysis. Okay, so for this case, you can do the predict. So now maybe you have a new method or new data set coming. Okay, based on this equation, so you need to have the maximum temperature, you have the total equipment run, and then you have the average equipment age. Okay, so you have a new data set. So you want to know about the what is the value for the energy. If let's say your maximum temperature is 7.65, okay, your total equipment 296.4, and then your average equipment is 88.5, and then you click OK. So now you get the fit. Here is the new prediction. Fit here is a predictive value for this setting. Okay, so based on this equation, with this variables setting, okay, and then you get the prediction for energy is about the 34417.1. Okay, so this one is how first you need to get the best model. After you get the best model, fulfill the assumption, you rely on this one, okay, and then you can do the prediction. Okay, so you can do the prediction. So based on this, you can say that, okay, based on this study, okay, the maximum temperature, total equipment runtime, the average equipment age is most important factor to the energy side. Okay, so based on this one, you have a 8, okay, 8 predictor, but only 3 are available on the best model. Okay, so after you realize this one is a good, so you can do the prediction. So this one is how regression will help you to solve your problem. Okay, maybe based on this one, you have others value for the maximum temperature, you include on this equation. So include this equation. So include in this equation. So you get the new or the new predicted value. Okay, so this pack. And then we go for another way. Okay, I already done for this one. Okay, satisfies all this one prediction. You now can do the prediction. Okay, so this one is a new added. Okay, starting with the Minitab 19. Okay, so this one is we call it the regression with validation. Okay, so the goal of the regression is to make accurate prediction. Okay, you want to do the something highly accurate. Okay, because you want to do the prediction. The two factor, okay, the two factor are impact the predictability of the model are the terms in the model itself, okay, and then are the sample data used to calculate the model. So models with too many terms, okay, too many terms, terms 2 is a refer to predictor, okay, or often overfit the sample but lead the poor prediction of the new data value. So basically you fit with the model with your data. Okay, your sample set, you get it in data you, and then you have the own models, and then you fit with this data set. But after you collect the new data set, okay, after you collect the new data set, okay, you pair with your same model because the same process, okay, you can see that with the new data set is not fitted. So we call this one is overfitting. If we compare with the new data set. If let's say you use the same model with the same data set, the old data set is a fit one. But now if let's say you coming, new data set coming, you fit with the old same models, you can see the overfitting here. So to avoid this kind of the issue, so they come out, the statistician come out with the, we call it validation. So what is the validation actually? Okay, validation is something like you split your data set to train data set and then to test data set. Okay, for example, you have collect 1K data set. Okay, you split to 2. First, maybe 70%. Okay, from that one, you use the trained data set. You build the model. Okay, the others, okay, the another 30%. So you test your data set. Okay, so you split your data set, not the use all the data set. Traditional way, we have a 100 data set. So we use all the 100 data set, build the model. Okay, but for the new one, we do something like split the data set. Okay, we split to 2, train and the test data set. We get half, maybe half, or maybe 70% to build the data, another 30% we test the data set. Okay, so method for validation, we have a 3. Leave one out validation. We have K full cross validation. We have the validation with a test set. So all these methods are available now for regression in Minitab. So how you can see it? We go to this one, go to stat, go to regression, fit regression models. You can see this one is a validation. Okay, so you can see this one is a validation. You go for the validation, so you have a K cross validation and the validation with a test set. Okay, so you have this kind of the features available now, starting with the Minitab 19. Okay, if let's say you're using the old version, so you're not able to see the validation in the Minitab. Okay, so let's we try. Okay, with this example. Okay, this example, basically validation is applicable when you deal with the big data set. Okay, so the common question is something like how many data set you consider the big data set. It will depend on you. Okay, but for us in Minitab, maybe it's general one, 1K. It can be a big data set, but it's a depend. Okay. So for this case, we have manufacturer of smart water investigate the what cause a bias in users reading. So this one is the predictor, is impact to users bias here. Okay, so all this data set is in here. Okay, so I go back to the Minitab side. Okay, and then I choose the water meter here. So you can see this one. So how many variables? You can go for the worksheet information. So here. So actually the data set is quite big. We have a 13971 data set. Okay. And then we have the 40 predictor. Okay. We have the user bias is our response. Okay, so based on this 40 predictor, which one is most impact into the user's bias? And then want to do the prediction based on this model. So this one is considered the big data set. So the same go for the stat regression, fit regression models. Why fit? Since more than one predictor. So for this case is users. This one is all the one categorical is the type. Okay. So for the validation, I chose the validation with a test set. Okay. So mean that now is a 30% is out of a 13971 is considered the test data set. The others one to build the data set, to build the models. Okay, click OK. And then for stepwise, maybe you go for the stepwise. So you go for the selection with validation. And then click OK. And then for the graph, maybe you check it back to the 4, click OK, and then click OK. Okay, so now you get the new regression. Okay, so based on the 40 predictor, only 2 are available in this equation. So based on this one, you look on the R squared. Okay, or you can look on the test R squared. Okay, so you look on this one is the value is higher, higher than 70%. So we'll consider that this equation is a good model to do the prediction. So you look on others variables. So here is a p-value less than 1. Maybe you can go for the assumption. Okay, you can look on the assumption. Okay, the Pareto. So K and C. K here is oscillation. C here is the tube size. It's significant to the equation. So you look on the assumption. So based on this assumption, you look on the test. So this one is a straight line. This one is something like constant. Okay, not the obvious pattern inside here. So also is scattered in the words 0. Okay, so all this assumption is fulfill the assumption, and then you look on the R squared is higher R squared value. Okay, it's quite good. And then you can use this value to do the prediction. Okay, so this one is the you using the validation. Okay, this part maybe the traditional way without the validation. Okay, and then Minitab will help you on the stepwise to choose it. Okay, the best model. Okay, the method to choose the predictor in your uh, equation or in your model. Okay. So for this case, already done it. Okay, so this one, and then your assistant. Okay, so others, you can consider in this one is something like assistant. Okay, but have a limitation on this assistant. So for example, I go back to the first example here. So you can go for the assistant, you can go for the regression. Okay. So for this case, is the fit. Okay, so this one, you have only two 5x variables only. So if let's say you have six predictor, okay, six variables, you never use the regression. So you need to back to the stat menu. So if let's say you have a less than, okay, less than 5, so you can go for the assistant. Maybe you can go for the, here is energy. Maybe I just choose only mean. Okay, you need 3 of this one, and then click OK. Okay, you can get the summary report. So you can get this kind of the information. Okay, so the same. And then you have a comment here. Maybe you want to see on the energy, your scatter plot here. Okay, your scatter plot. And then you have residual here. Same. You have assumption here. And then you have the fit model equation here. Okay, your model equation. And then maybe, of course, you can get the report card. Okay, so the differences between using the stat menu with the assistant menu. Okay, but for the system menu have limitation for this case. If let's say you big deal with the big data set, so you're not able to see on this one. Okay. Okay. So do you have any question? So if let's say you have question, please type them into the Q&A session or in the chat box. Okay. So if have time, I will answer in this one. If not enough time, I will answer it by the email after this webinar. Okay. Okay, so if let's say you want to this material, so drop your email into the chat box or into the Q&A box. Okay, we have one question here, how to determine the value of alpha to enter it. Okay, so this one is something like, okay, I will go to the that one. Okay, so the step menu, go for the regression. For the fit regression, we have to, okay, sorry, here, back to this case, strategy. This one, okay. Fit regression. Okay, so go for the stepwise. So you can see on this stepwise, you have the enter and then the remove variables. So for this case, for the stepwise, basically we try with the because this one is automate, so we want to stepwise directly go to the final model. So for use for safe, you will use the bigger alpha value. rather than the normal one, something like 0.05 always we using. But for this case, maybe you can use the more than 0.05. Okay. Because to enter and to remove the value for this case. Okay. So if let's say you want the one use the stepwise in the Minitab, you can do manually. Okay, look on the p-value here. Okay, p-value here. So if let's say less than 0.05, so it's significant, remain in the model. So what coefficient for this value, you can go for this coefficient value. So you can build your own model for something here. Okay, for example, here is a maximum. Okay, so this coefficient is from this value. Okay, so you can look on the coefficient table. Okay, so maybe you look on the p-value first. Okay, you look on the p-value. After that, is significant, so you can go for the coefficient to have the coefficient value for each this one. Okay, to build your own model. If let's say you want the one using the Minitab to help you choose for the stepwise. Okay, so the option we have. Okay, hopefully answer your question. Okay, others question? Okay, we have another question is what could we do if the R squared and R register are low or are low with the 25%? I think this one is unique to something like one. Okay, go back to the regression. Okay, go this one. Okay, go for the regression. Here is energy. Here is something that one. Okay, you need to play around. Sorry for this case, because this modeling is you need to try and error. Okay, it's a try and error. Here, go for the models. Okay, if let's say you already know, okay, the mean temperature is not good. Okay, it's not have any correlation with your energy, so you can remove this one. Okay, for this case, you can remove. Or maybe you have interaction between this value. Okay, you can add the value here. Okay, you can add the value. Okay, you need to try and error. But of course, for today's session, I just focus on the regression side. Maybe before you go for the modeling, maybe you can go for the stat, maybe you can go for the graph. Okay, graph builder, something that one. Maybe you can go for the scatter plot. Okay, scatter plot. You want to look on the Y your energy, your X is the mean temperature, maybe your okay, with the minimum temperature, okay, maybe you can go for the maximum here, and then maybe you can create something that one. So you look on one by one. Okay, after you realize on this, have the relationship, maybe you can go for another way. Okay, so or you can go for graph. I love this one. Okay, parallelogram. Okay, for example here, I go to this data set. It's a big data set. So I go for the stat, graph, I look under parallelogram. So if let's say you have a lot of predictor, so want to see on this one, so you can go for the parallelogram. So you can display the correlation value. Click OK. So on this case, okay, so you look on this one, this value. So you based on this value, you can see that oscillation is a cube with the energy, okay, have a correlation with this one. So this will help you before you go for the regression side, okay, before you go for the relationship or so on, okay.